Transformation. A transformation, put this in your notes, is a change in the position,
shape, or size.
There you go. Change in the position, shape, or size. Of a geometric figure. Anyone want to come click these? They move, it's fun.
No.
Thanks, we'll go out there. Click one and then ask the class what it did. Go click a red triangle. Well, they're all red, but. Ooh, what's that, guys? Rotation. Click another one. Ooh, what's that? This disappearing isn't one of them.
Why did it?
Translation. Ooh, what's that? Dilation. Reflection. Thank you, Kendall.
I know.
What? It slid off the screen. You missed it. It went like this. It went.
But like, why is it back yet?
Because I didn't program it to come back. I just programmed it to leave.
Forever?
Are you really worried about this? Okay.
That is.
Here. Oh no, it is gone until I reopen the file again. It's gone. Yeah, you're right.
Exactly.
Anyone want to pop the bubbles?
Me?
Come pop. Types of transformations. You need to sketch a little picture. Okay, she chose dilation first. So sketch a little picture of a triangle.
Okay, I'll say translation.
A dilation is also known as a resize. So if you could write the word resize next to it as well. We've got the real word and the slang word. So dilation, resize. Go ahead and click another one. Rotation, the slang word is turn. It's really just a turn, like you're turning a doorknob. Go ahead and click them all so you can sit down and you can write it down. There you go. Good. Reflection is a flip, and translation is a slide. So each one of these has the geometric word and the everyday word. Would you ever be like cooking breakfast on Saturday morning and be like, I reflected my pancake?
No.
No, you'd be like, I flipped my pancake over. I just reflected the pancake. Or do you tell someone to like rotate the doorknob? No, you say turn the doorknob.
Why would we tell someone to turn
What? I don't know. Yeah?
Can you use it? Can you use the door? You would say turn the door knob.
Okay. Who needs more time? Raise your hand if you need more time.
Yeah.
So today we're going to focus on translations and reflections. We're going to focus on those two today.
Bam.
Moving on?
No.
Just keep moving. Well, but we're not swimming in this class.
Or not.
Okay, 5, 4, 3, 2, 1. Time's up. It's okay. All right, so now let's focus on translations. A translation is a transformation that glides or slides all points in the plane in the same distance in the same direction. Same distance, same direction. Yes. Oh, I like it. SL for slide. When did you learn it first time? In like middle school?
Yeah, 5th grade.
There you go. Translate. SL, slide.
And then
Very
S.
clever.
Yeah, in
Do you need something to help you remember what a translation is? I thought you just knew it.
and reflection is
FL for flip. Oh, she knew it too. Look at y'all. When you translate a figure, do you change the size or the shape?
The shape.
No, you don't change. Oh, I didn't mean the size or the shape. I meant, do you change the size or shape? And the answer was no. So the image is congruent to the pre-image. So you start with the pre-image, you translate it, and they are congruent to each other. So you don't change the size or the shape. Okay. So you've got a triangle ABC. First, you need to find the coordinates. I'm going to call on you. So find coordinate A and write it down. Find the coordinates of B and write it down. Because in this unit, if you can't plot points, you're going to have trouble. So let's practice plotting points. Jeanette, go write the coordinates of A. Philip, go write the coordinates of B. And Catherine, go write the coordinates of C. Go when you're ready. She fixed it. Oh, no. She didn't fix it. Whoa, wait. Negative. Backwards. 1, 2, 3, 4, 5. There you go. There you go. You got it. She's just so perfect. She gets to make fun of everyone else.
No, it's not.
Tell me the wrong.
It's -7.
It's
Negative 7.
-7.
Do you need help? Do you need me to teach you how to plug in this?
Yes, he needs help. He needs help.
Jeanette, tell him that's -7.
1, 2, 3, 4, 5. Cool. All right. So that was the easy part. Now let's actually translate it. Where is it going? Where are we moving it?
5 units right.
5 units right, and 4 units up. So you take each one, and it's kind of like slope. You take point A and you go over 5, 1, 2, 3, 4, 5, and then up 4, 1, 2, 3, 4. Does it? And we call this A prime. That's really important. Does it matter if I go up 4 and then over 5, or over 5 and then up 4? Does it matter?
No.
Does not matter. You can do that in any order you please. So go ahead and draw the new triangle. I'm going to come around and look at it. Draw the new triangle A prime, B prime, C prime. When it's the point and you've moved it, you put a little tick mark next to it, and that's called prime. Kind of like Optimus Prime, right? A prime, B prime, C prime. Can you translate your points, please? Right 5, up 4. And draw the new triangle. Yeah, draw it in orange.
Okay, I got it.
Did you bake something? No. Did someone in your family bake something? Did you buy brownies at the store?
No, right here.
Okay. Connect the dots to make a triangle, please. Kenneth, what are the coordinates of A prime? 0, 6. Kendall, B prime.
-2, 1.
-2, 1. Brett, C prime. Oh, we have 2 new students right there. Didn't I introduce them last Thursday?
I wasn't here.
Matt and Brett.
That's it. Yeah, I don't say it. Don't say it. I don't say it.
7, -1? Cool. All right, any questions about translating? What happened to my x values? If we were using math, how did we get from here to here? What did we do to the numbers?
-5.
You added.
What?
You added 5.
Add 5. Perfect. So we added 5 to all the x values. What do we do to the y values?
4.
Added 4 because we're going up. So from here to here, we added 4. So from here to here, we added 5. From here to here, we added 4. So can you translate without using a graph?
Yeah.
Sure you can. Yes. Okay. Do the next one. Go. Do it on your page.
No.
This time we're going right and down. 2 right, 1 down. D prime, E prime, F prime. Is your end result going to be overlapping or not overlapping?
Overlapping?
Yeah, it should overlap. Ooh. Leah, give me these three coordinates.
-7, 3, -5, -5, 2,
Everyone okay with those? Check your answers. All right, so we're going to take the x values, and what are we going to do to the x values? Is everyone okay with that? Did you hear?
Yeah.
Add 2. -7 plus 2. -5. -5 plus 2. -3. 2 plus 2. 4. Yeah. Okay, what do we do to the y values?
You
Add
add 1.
No, we don't.
-1.
Down. Subtract 1. 3 minus 1. -5 minus 1. And 5 minus 1. Look good? Yes, ma'am. Move on. We're bored? Okay, great. Oh, look at Mr. Frog. He's so cute. Do you see the frog eating the fly? Mr. Frog has been translated. Find the rule for his translation. So we actually, we haven't been writing the rules on the other slide. Let me go back to this one and tell you how to write a rule. So on this one, what was our rule? What did we do to the x values? Add 2. Thank you, Torin. And what did we do to the y values? -1. So write the rule down. I'm sorry we left that part out, the rule. What's the rule for example 1?
5 plus
X plus 5.
And y
4
plus
minus 5
X plus 5. Y
minus 4.
plus 4. Up, up, up. Up is plus. Down is minus. X plus 5, y plus 4. And x plus 2, y minus 1. So now we made the translation. The translation's already done, and now you have to write the rule. So what happened when we went from A to A prime? What happened to x? Is it? It's not on your paper. It's just up here. Oh, okay, Mr. Frog.
Down 9.
Let's see. And I'm counting the boxes. I'm not counting the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at Kendall. Down 9. What does that mean? X minus 9? Y minus 9. Very good. So y minus 9, that's the y part. And then what about the x part? 1, 2, 3, 4, 5, 6, 7, 8, 9. What do we write? X. Did it go positive direction or negative direction? Positive. X plus 9, y minus 9. Questions about writing a rule? How to write a rule? No? Okay. Okay. I wrote the verbal description. You write the rule. Go. Write them. Yeah, right there. Okay. 3 units right and 4 units down. Write the rule. I'll give you an example. 3 to the right would be x plus 3, and 4 down would be y minus 4. When you go down, it's minus. When you go right, it's plus. So you do the next two. Example 5 and 6. Ashley, go write your answer for 5. And Lewis M., go write your answer for 6. didn't trick Ashley. I tried to. I put the y one first, but she didn't use it for the x one. She did great. X minus 6 because left means minus, and y plus 8 because up means plus. Change it if you got it wrong. It's x minus 6, y plus 8. Because left and right affect the which axis? Left and right. X-axis. Good, Dimitri. And up-down affects the y-axis. Okay. And then, Lewis, it looks like you did perfect too. X minus 2, x minus 7. Left means minus, down means minus. Ask me a question.
How's your day?
Oh.
Good
Wonderful.
answer.
Wonderful. Okay.
Oh my god.
Next one. You're up. Go. Go. Describe it in words. Kendall, describe number 7 in words.
5 units left and 4 units left.
Everyone write it down. 5 units left and 4 units, what'd you say? Up. Okay. Ava, what about the second one?
3 units right and
Nice. 3 right, 1 up. We like this unit? Easy? Tight? Dimitri, number 9.
2 units left. And 1 unit.
In 1 unit. Perfect. I'm going to move on because I think we got it. We got that. We're great. Okay. So, what time is it? We're going to do, flip it over, we're going to do reflections. Yeah, that way we'll have one day where we can just do a fun activity. Okay. Flip your paper over, get it, flip it, because we're about to do reflections. Flip. Okay. So we're on the reflection side. It's a horrible joke, it wasn't even funny. A reflection is a flip across a line. We are always going to reflect across a line.
Well, we didn't have those cross lines.
Normally, it's going to be the x or the y axis, but we can also reflect over other lines as well. So did you fill it in? A transformation that? Maybe it's on the next slide. Nope. Is it on that slide? Nope. Okay, so what's your blank?
A transformation that something.
Yeah, I would put flips.
Isn't it crosses a line?
No. It doesn't cross a line. Reflection, I would just put flips.
Yeah, Megan.
And then in the other blank, write the word congruent. The image, even though you're changing the orientation, the image is still congruent to the pre-image. You're not changing the size, and you're not changing the shape. You're not changing the, what did I just say? You're not changing the size, not changing the shape. The one you start with is called the pre-image, and the one you end up with is called the image. Like if you're looking at yourself in the mirror, the real you is you, and then what do you see in the mirror? What do you usually call that? That's your reflection, your image, okay? So the image is not the original, not the real you. The red one. Okay, so the black one is the original. The black one's the original. Julius, what is the red one reflected over? The black is the original. What did we flip the black over to get the red? What? The axis. Okay. Yasmin, what about the green? The x-axis. Very good. Okay. So those are the ones we will flip over most often. Here's some pictures of reflections. We've got like a marina, we've got an astronaut, we've got a bug's eye, we've got a lake, we've got a war memorial, a marble. That's a rear view mirror. That's a bug's eye. Yeah. It's all green and slimy. Okay. Anyways, lots of fun reflections. All right, let's practice. Reflect that puppy. Over what? What are we reflecting it over? What's it say? Please reflect over the x-axis. How are we going to do that? Turn it upside down. Okay. Fold it.
I'm gonna fold it.
Okay, how far away? We agree that we're reflecting it over this horizontal line. How far away is A from the x-axis? 3 away. So if you want it to be a perfect reflection, you need to be 3 away. 1, 2, 3. You don't move it left and right. You only move it up, down.
So when the reader you would add 6, subtract 6.
But that's not going to work for all of them. Well, I'll show you the rule. The rule is really easy, actually. But yes, for A, you would subtract 6. Yes, you would. How far away is C from the x-axis? 2. So how far away do I travel from the x-axis? 2. And how far away is B? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, let's see if we did it right, because I have the answer right here. Yay! Perfect. That is that figure flipped over. All right, now let's see what the rule is. Who has the coordinates ready to go? Anyone? Okay, Kendall, let's go. 2, 3, 4, 7, 7, 2. Okay. Megan, what are the coordinates of A prime?
-2, positive 3.
Positive, just switch those. Positive 2, negative 3. Over 2 to the right, so positive 2, negative 3. Okay, I want you to look at A and then A prime. How is A related to A prime? They're the same?
They have a negative.
Coordinates are all
What has a negative? The Y value? Dimitri.
The numbers are all the same. It's just
The Y value became negative, okay? Travis, what about B prime? What are the coordinates of B prime? 4, negative 7. What do you notice about B and B prime? What's their relationship? They're the same except the Y is negative. Who, for Snickers, who can tell me the rule to this reflection? The rule. XY becomes, raise your hand. XY becomes, ding, ding, ding. XY becomes X negative Y. You need to write that down. That is the rule. That's the rule. X negative Y. So if you're flipping over the x-axis, what do you make negative? The y. What do you think is going to happen when you flip over the y-axis? Yeah. Okay, let's fill in C prime. 7, negative 2. All right, do the next one, please. Reflect DEF over the y-axis this time. Would anyone like to draw the reflection on the board? Anyone like to draw on the smart board? You don't know. You just count how many away. Okay, come do it.
Let's take off.
Call it F prime.
Oh. And then we go from here, right?
Yeah, how far away is E from the y-axis?
9.
Okay, then go that far away.
And that's E.
E prime.
7.
Yay! D prime. Put little primes on all of them. You can't have 2 D's. Yeah, a little tick mark, tick mark, tick mark. Awesome. Thank you. Okay, I'm done. Thank you, Torin. All right. This is what your figure should have looked like. Nasia, what's the rule? XY becomes? You got it. When we flip over the X, we made the Y negative. When we flip over the Y, we make the X negative. So what would XY become? Negative X, Y. So when you flip over the Y-axis, you change the X. When you flip over the X-axis, you change the Y. Thank you for listening. Okay, let's move on. I don't think we need to do this. What do you think?
No.
Nah.
Cow.
All right, here's a summary. You need to write this down. If you reflect over the x-axis, the rule is x negative y. If you reflect over the y-axis, is it anywhere? I don't know. It's in the middle. It's in the middle. The rules. Yeah, the rules. That's what all three of these are, those three rules. The one we didn't do is we did not reflect over the line y equals x. And the rule for that one is the y and x, they trade places. Like Freaky Friday. xy becomes yx. Never want to do that. So now you have all your rules. Is your rule box complete?
Yep.
Okay. What line has the star been reflected over? It's not the x or the y axis. You have to name the line. Huh?
-1.
Well, no, it's not. It's none of the ones in the box.
-2.
So you find the middle.
0, -2.
What?
0, -2.
No, that's a point. It can't be a point. It needs to be a line.
So, number, yeah, -2.
That's a line? I think that's a number.
Y equals -2.
Y equals -2. Ding, 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 ding. Write it down.
Close enough.
It's y equals -2. That's a y equals line. Do you know how to tell? Do you know how to tell whether it's a y equals or an x equals? Guys, to get to the blue line, would you travel on the y-axis or the x-axis to get there? I'm right here. How would I get there? Travel on the y-axis, and now I'm there. So whatever axis you have to travel on to get there, that's the one, that's the letter you pick. Let's try another one. What line has the check been reflected over?
X equals.
Yeah, it's fine.
4.
Yeah.
Is there anything in it? X equals 4. Write it down. X equals 4. You travel on the x-axis to get to that line. I travel 1, 2, 3, 4. Oh, I'm there. All right. Oops, I skipped a slide. Reflect the rectangle over the line y equals x. What does the line y equals x look like? Think about algebra. Y equals x. What does that line look like? Does it look like this, or this, or this? What does it look like? You don't know? Yes, diagonal. It's the diagonal line. I have it hidden here. Oh, there we go. Yay! That is y equals x. That's important to know. So what is this shape going to look like when we flip it over? Can you draw y equals x in? You go through all the intersections. Look, you go through that box, that bond, right through the intersections.
Right in the middle.
Right through the middle. Yep. What is it going to look like when we reflect this? What's the rule? Let's find this coordinate. This coordinate is 2, 3. 2, 3. What's the rule for reflecting it over the line y equals x? Look at your little box of rules. Matt, what's the rule?
Basically, let's switch.
You're gonna flip.
So that'd be 3.
So what does 2, 3 become? What's the new one? No negatives. The negatives. 3, 2. Yeah. Okay, so everyone needs to plot 3, 2. We just trade places. Freaky Friday. Trade places. 1, 2, 3. 1, 2. So there's our new corner. Grab another point. The next point is 2,
8.
8. Very good. 2, 8. Freaky Friday. Trade places. What does 2, 8 become? 8, 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And then from there, I would just figure out how long this thing is. This is 1, 2, 3, 4, 5, 6, 7 long. 1, 2, 3, 4, 5, 6, 7. Okay, all done. So I plotted those 2 points, and then I just counted how long my shape is, and there is my shape reflected over the line y equals x. So it goes from here to here, from here to here. Okay, a couple more things. Symmetry. What does it mean if something's symmetrical?
If it's same on both sides.
Same on both sides, like a mirror image. Very good. Equal, congruent. How many lines of symmetry does a hexagon have? Start drawing them on your paper. Draw some lines of symmetry. Let's see, I could cut it in half. This way. This way.
It has like 8.
Four.
Infinite? 4? 8?
Five. Four.
What'd you get, Megan?
6.
You were on fire today, and I'm tripping over the smartboard. 6! Yeah! How many sides does a hexagon have? 6 sides. It also has 6 lines of symmetry.
5 seconds.
What about a pentagon?
5.
You're wrong. Just one.
I don't know.
Connect every corner to every side.
You're wrong.
Connect every corner to every side. Connect a corner to a side, a corner to a side. How many does it have?
5.
Wow, imagine that. How many sides does a pentagon have?
Who's right? You're wrong.
So a given polygon will have how many sides, how many lines of symmetry?
5.
In. What does in stand for?
Number.
The number of sides. Yep. We're not going to do this. Okay, last thing. When you translate or reflect an object, the image is blank to the pre-image.
The image.
Congruent. Write the symbol. You don't have to write the word. Be in.